This conference is brought to you by CallStack, a total software engineering consultancy.
Very nice to see everybody here. Thank you again for coming. Really excited to give this talk. Now, it is a lightning talk. We're going to be going lightning fast. Now, I'm going to make sure I go slow enough. We're going to have a lot of information. It's going to be jam-packed. And the goal today is for you to become the performance SME for JavaScript and React Native. You want you to be the go-to individual on your team where if a performance problem happens, they come to you and say, hey, Mike, how are we going to solve this? What are we going to do? What can we do to take a systematic approach to solving the performance problem in our multi-platform React Native code base? So we're going to take a little bit different approach to this presentation. Really excited to try this out here. So we're going to do it more of a hypothetical situation, right? We're going to set the stage. We're going to create a hypothetical where we're going to walk through a performance problem, and it's our job to identify, analyze, and find the root cause, and then come up with a solution so our team can be happy and we can deliver a very delightful, performant product to our end users. So your team of engineers is finalizing one of the most impactful feature releases of the year for your React Native application, targeting 5+ different platforms, maybe 8, maybe 10, right? And you're probably thinking, Mike, how do you have so many platforms? Like, there's not even 10 platforms. So just think to yourself, like on TV, we got FireTV, we got Android TV, we got tvOS, which is Apple TV if you're not familiar, right? We got Tizen, right? There's Vizio. There's LG, right? There's similar flavors, right? And then you just keep going. You're like, okay, well, how about tablet? You got Fire Tablet, right? Some of you have Fire tablets, right? That's a little different. You have Android tablet. You have iPad. You move into mobile. You have iOS, iPhone, right? And you have Android phone, and then you got web. Don't forget about web, right? That's how React started, on the web. So, and your goal is to solve the performance problem and, again, deliver a really delightful user experience to your end users, performant experience, right? So let's keep going here. It's 3 days before the release date, okay? Everything always happens 3 days before the release date. Everybody knows that, right? And on Friday, right? So the perf testing team sends you a message. So some teams, some organizations, depending on size, depending on scale, will have an individual that's testing the performance. You probably have tools in your pipeline that help with you, that provide you these metrics over time. But sometimes they sneak through, right? Maybe you're not tracking one, right? And it's an important one that you're just like, something happened. But your perf testing team sends you a message, maybe on Slack, maybe on Teams, and they say, Mike, the performance needs significant improvement. We cannot launch in its current state. You're like, oh, okay, we can do this. We can figure this out. Let's take a systematic approach. Let's do it like a science experiment. We'll go through the steps of, analyzing, understanding where it could be, and, finding the source of the problem. And then we're going to find the solution, right? And we're just going to be systematic about it. Again, I know a lot of developers, and this isn't a bad approach, they get in there and they go, okay, let's look at the code. It's just going to show me the answer. I think I know where it could be. And then, in this hypothetical, let's make it a little harder. So you have 1 million file code base and 100 million lines. Okay, so now you're going to just start looking, right? You're going to open up your VS Code and go, I'm going to find it. I'm going to find the problem. I'm going to throw console logs in there, right? I'm going to throw some debugger statements. Maybe I'll find it. I'm going to start commenting stuff out, right? It's an approach. And sometimes it works, right? It just might take longer, right? So let's take a different approach here. So let's do the investigation. Let's start the investigation. What's an important step in starting the investigation? Well, we should gather the facts and the preliminary data, right? What do we know already, right? Without even actually having to open up any text editor or ID or anything, right? Let's pull the facts out that we already have. What's the end user experience related to the performance problem? Well, slow home screen load. Everybody has a home screen, right? Slow home screen load. Screen-to-screen navigation latency, right? Going from one screen to another screen is slow, right? And degraded video start time. Now, again, that's a very streaming or TV-based KPI, if you will. This KPI is very much is very important, and it means how fast did your video actually start? How fast did you see something on the screen and start watching, right? And this, if you can believe it, degrades heavily if you make certain types of mistakes. So that's one of the key indicators that we'll look into. Moving on here. Is it isolated to a single platform or multiple platforms? This is a very important question to ask, right? We have a multi-platform code base. Is only one slow right now? Did we write platform-specific code maybe on the native side that's all of a sudden, not performing well accidentally? Someone shoved something in there that's just ill-performant, right? Well, in this case, guess what? It degraded on all platforms, so that's a clue. We've got to keep that in our minds, right? We write it down, right? I literally write it on paper. Okay, it's affecting all platforms. Okay, what else? Have you spot-checked memory consumption? Now, this is where things get weird, right? If you are kind of thrashing your memory, high memory leads to very weird behavior, right? So it's good to check this and see what's going on because it's very easy to check, right? Android Studio, you can do it. Xcode, if you're targeting one of the Apple-based platforms, right? Good tools, easy to use, very easy to rule out whether or not memory could be the issue. In our case, not too bad, right? We had to check on one of the platforms, and in this little, GIF here for our example, we checked on iOS, and guess what? Not too bad, right? Not too bad. So we ruled that out. Okay, so let's go ahead and form our hypotheses. So this is like the science experiment part, the fun part. Like, what could it be based on the data we have now? And what can we infer based on what we know? So let's make these hypotheses. Degradation due to unnecessary re-renders. Okay, it's a common problem, right? Everybody uses React. And a lot of people say, that's not enough, especially on the web. I hear this a lot, and this is okay because it's usually true on the web when you're targeting desktop browsers. You got all that horsepower, you got all that CPU and memory really backing you, and the browsers are usually very performant these days. And guess what? This might not affect as much on the web, but how many people have dealt with like a FireTV Gen 2 stick? Anybody? Okay, call stack, folks. Yeah, absolutely, right? That's a challenge. I love that challenge, right? You don't even expect to run JavaScript on a device like that. But that's where the fun part comes in. So that's where you really got to dig in from a performance perspective. So re-renders matter in that case. But let's talk about another hypothesis, right? Because that's not the only case, right? If we know it's targeting all platforms, a problem might be in the shared code, might be on the JS side. We're kind of thinking about the JS side now. Degradation due to time spent executing expensive JavaScript functions, right? This is like the long piece, right? Okay, you wrote a function and you called it, and now it's just, that function is quote-unquote slow, right? It takes a long time to execute, right? So we have two hypotheses. This is a good start, right? Okay, what is the next step? What is the next step? Well, before we dive into the next step, let's talk about the application overview. What does our application actually look like in this case? And usually you know what your own application look like, but for the sake of the demo here, or the hypothetical we've created, we're gonna show you this structure, and we're gonna talk about the parts. And this technique a lot of people use. I know a lot of speakers use this technique when they're building out something new. I'm sure a lot of the developers here also use this technique, but you can also use it when you're actually like retroactively trying to learn an application, right? This helps me. This is what I did when I got to DirecTV, and I was like, okay, let's understand how this thing's actually composed. So I just started drawing boxes, right? So here's what it looks like, and then I have my VS Code file explorer over there on the right, and you got the application on the left, right? So let's just start drawing boxes and pointing arrows and kind of understanding how this is composed. We have the back button, obvious, right? Sometimes applications don't need this back button, right? If you're building for web, you got the browser baked in back button, so you might not see that, but some do. Some apps do still put it. So we have our back button here. Let's keep going. We have a card, right? Some people call it a content card. Some people call it a card. Some people call it a tile, right? But we can see what that looks like, right? We then have content, right? And this is the outer piece, right? The outer kind of wrapper of all of the other, one of the components we'll call out next, the horizontal lists that we see, and the vertical kind of separated lists as well. And then we have a home screen. This is like the outermost wrapper, right? This is the outside, right? The outer container, whatever you want to call it, the screen, right? It's called, in this case, just the home screen. We have the imperative flash box. Okay, what is that? Well, that's just for this demo. I built this so it basically imperatively flashes when I press the button, when anybody presses a key on your remote, right? Key on the remote is not a web thing. Again, I bring that up a lot because this might be foreign to a lot of people. For TVs, you have a remote and you have focus management, right? And a lot of you always probably hear that word and you go, oh God, not focus management. This is not good. It's hard. Focus management is hard. And for this demo, when you press a button on your remote, you'll see a flash in the top right corner, and you'll see it immediately because I'm doing it imperatively, right? I'm literally assigning the styles, right, directly, not going through a render cycle, right, not declaratively. I'm directly flashing this on the screen imperatively, okay? So you can understand the timing of how long something took without actually being the one pressing the remote. So really key to understand, when that flashes, that's when I press the remote during this sample kind of demo here, right? Let's move on. We have the swim lane. That's the outer component that encompasses, or the list that encompasses our content card or our card in this demo. Okay, let's move on. We have testing our hypotheses. Okay, so hypothesis 1, degradation due to unnecessary re-renders. All right, this is a great hypothesis at this point. We have a lot of preliminary facts pointing in this direction. We try it out. We pull up our React Native dev tools, and we pull up our profiler. We record a re-render profiler, right? Different than a Hermes JS Sample Profiler, right? This profile is going to show you re-renders and also the time it takes to re-render. But guess what? Guess what? You tested this. You tested your hypotheses like you should test, and you find out, oh man, this is good. Well, you shouldn't say, oh man, right? Because again, this is, if you fully optimize your app for no additional re-renders, unnecessary re-renders, you should be like, this is great. We're doing a good job, but we got to find the actual problem now, right? So in this case, not the root cause. Let's move on. Let's keep testing. We have another hypothesis, right? Let's test that next one. Degradation due to time spent executing expensive JS functions. Okay. So how do we do this? What tooling do we have? This is where the Hermes JS Sample Profiler comes into play. Excellent tool, right? This could be the one that is going to save us and save our release and deliver the value we want to deliver to our customers from a performance standpoint. Okay, so again, before we jump in, let's define the user journey. What is the user journey where this degradation is being seen? That's important because that's what we should profile, right? That's what we gotta record and then analyze, right? So we're gonna do the baseline here, right? We usually have this kind of in our back pocket. We have our maybe previous releases, profile, and we're gonna walk through it here. We're gonna launch the app, we're gonna set focus to the back button, and we're gonna start the profiler. We're gonna press down 2 times, right? Pressing down 2 times. We're going to press on the library, wait till it loads. Then we're going to go ahead and go to the detail screen. Then we're going to wait till it loads. We're going to press back. Then we're going to stop our profiler. Okay? We're going to watch it again just because I know that was quick. You can just watch it go through, right? And again, this is the baseline. This is the baseline, right? Here we go. And again, what you saw, I pulled up my prompt there, my terminal, because I wanted to engage the dev tools. I wanted the dev menu to show up, and I can start my profiler. And again, I want to emphasize that this isn't the only way. And in React Native 75, there is another means to do it. I know you saw the presentation on the new debugger coming. That will also have the profiler baked into it. You just press the record button. So it's a lot easier. And then there's also the new, released in December, I think, of 2023, the React Native Release Profiler package, the open source package. The person that wrote that did a great job. Integrate it with your given React Native app, and you get a release profile, which is even better. It makes it easier to analyze. But this is going to do for us in this case. So let's keep going. Okay, the user journey with degradation. We're going to do the same thing. And I want you to focus on what happens when we press the library. And there it goes. Wow, that was slow. That was real slow. That didn't feel good. Our user's like, what is happening right now, right? I mean, I don't want to be a user of this application if all of a sudden I'm waiting months for my library to load, okay? So again, you can see this go through, and you'll see it even after I pressed the stop of the profiler. You get a nice little path here. So we're going to get into that. What is this path? It's telling me save results to blah, 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 blah. And disappointingly, this path is not correct. So disregard this. And this is real. This is a real profiler. It's just pointing you to the wrong spot. So we're going to find where it actually went. Where the heck did it go? And you don't have to do this, but it's good to know where it is anyway. And you can use your tooling, your Android Studio in this case, to find it. So let's do that. Let's check the cache on Android Studio. You can do it with the Device Explorer. So make sure you go ahead and click your Device Manager icon. Make sure you select your physical device, right, because that's the one we're working on. You're going to press the Device Explorer icon. Then you're going to navigate to the appropriate directory, and you can find this. You can explore around. It's good to know how to navigate through all the folders on your Fire TV or your Android TV, right? They're available for you. So you'll find your sample app here. You'll go ahead and open it up, and you'll see right there, it says sampling profiler trace, a bunch of characters, and then .cpu profile. That's the one we want. We just recorded that, right? And if you record another one, you'd see another one show up there, right? And you can even delete it from there, but we can't just pull it off. You technically could. You could just pull it off the device yourself and then transform it with another special package that they have that lets you do it. But there's also a built-in tool to do that, so let's use that from the command line. But before we do that, let's go ahead and talk about the techniques that we got to use once we get that profile off the device, right? Again, the goal is to understand what we're trying to do, which is find the source of the problem for performance. And one of those means is analyzing this profile that you see on the right. And there's two specific techniques that work very well for me. I use this all the time. And it doesn't have to just be during what we call performance fires. Like, put out the fire, make the performance better, Mike. Come on, you can do it. I know, you've done it before, right? This can also be proactive, like proactive performance improvements. You could just do this on your app now and find problems and go, wow, that seems slow, and then write it down in your notes. Oh, that one seems slow, that call seems slow. Write it down in your notes, right? Then circle back and start improving those areas, right? So let's go through these techniques. Identify long-running JavaScript functions. Okay, how do you do that? Well, you look for the wide blocks in the flame graph, right? The wide blocks that don't have any or minimal subbars, right? So again, you want to find the wide ones that don't have a subblock and a subblock and a subblock and a subblock, because that one's encompassing all these other calls, so it might not be the problem. So let's look for a wide bar that doesn't have anything underneath, or a wide bar that only has one or two things scattered underneath, right? And you want to look the furthest down, right? So, and then next, investigate recurring call patterns, especially calls found in number 1, right? So if you see a wide bar, zoom out and search. Just do a control find, right? Control find, see how many occurrences happen. Now, this is a sample profile. It only takes a snapshot every 10 milliseconds. A lot of people don't understand that. And you'll see GitHub issues filed against React Native that says, my function's not showing up here in my super small demo app that I wanted to try this out on. Why isn't it showing up? And they go, it's a sampling profile. It's only going to take a snapshot of what's happening for function calls every 10 milliseconds. Otherwise, the device would probably crash because it would have to do too much work and gather too much data, create a file too big, right? This file can become huge. So it's a sampling profile. So you might not see every call, but the ones that you do see and that you see often, it's a sign of a problem, right? So we're going to zoom out and we're going to search and we're going to see how many of these calls from number 1 we find during number 2. Right? In this case, you can look at our example, right? This is really from our example. We pulled this during our investigation. We see clean up data in store, and it's happening a lot. Clean up data in store, clean up all data in store, clean up all data in store. Oh, okay. Why are we cleaning up so much data in the store? And why do we keep doing it over and over again when we're going from, when we're pressing the library and the library needs to load? What the heck could be happening, right? So let's now actually pull that profile off the device, right? And then we'll use our techniques. We're going to use our techniques that we just talked about to analyze the actual profiler. So how do we do that? Well, we go ahead and run this very nice command, React Native, profile Hermes, give it the path. It'll pull it off the device and save it to your local. Then all you have to do is upload it here to Chrome, via the Performance tab. Once it uploads, you'll see what you just recorded. You have that insight, what you saw in the previous screenshot. Then you can start using the techniques we talked about, 1 and 2, right? Wide bars furthest down on the flame graph, right? And then zooming out and searching for that. See how many times it happens, right? And in this case, maybe we found another one, right? Maybe there's the use swim lanes action that's happening a lot, right? Maybe that's a second thing we should look into. But first, let's look at the worst one, right? We saw, wow, that use cleanup data in store, that's heavy. That's heavy. That happened a lot, right? Okay, so let's go ahead and locate and assess the performance problem, right? We found this function. It gives us the line and the metadata in the profile as well when you click on that bar. We're going to use that metadata about the line number, the function name, and the file name, go into our code base and pull it up. And although we're not at the actual function here, usually you look at the function and you go, okay, here's the function. Okay, let me start looking at the function. Well, maybe look one level higher. Maybe look at the call sites of that function. That could be the problem, right? The call site of the function might be the problem. We know it's called a lot, but why is it being called a lot? Right? Then we can maybe optimize the guts of the function, the implementation details. But let's see if we even need to call it so much, right? So in this specific case, right, we go to this file, we locate where it's being called from, we find out what's actually happening, we look on the hood, and we find out it's using a use effect. Oh man, use effect, right? It's using a use effect, and it's using the cleanup function of the use effect. And it's cleaning up all the data in the store, and it takes a while. And then you're like, okay, well, they're cleaning up the data, all right? Okay, but why is it called so much, right? Well, where is this call happening? It's happening in the card. We know we render this card a ton. We painted a lot to the screen, 100 times sometimes, right? We got a lot of those cards, right? And that's how you get to your movie, right? You press it and you want to get to your movie, right? You need those cards. You can't just get rid of them, right? But why is the cleanup happening there? It doesn't make sense, right? Well, let's figure out a solution then. What could we do? What could we do to fix that? Well, it actually ended up being very easy in this case in our hypothetical situation. Move it up the component tree, right? We actually didn't need to call it 100 times. We actually just need to call it once when the screen transitions, right? So again, we were on the home screen. We changed focus from home to library, we pressed library, and on press, all these use effects, cleanup calls get called, right? And that's where our performance problem was happening. So all we got to do is move it up, right? Move this up to the appropriate place. That ends up being our in-ear content, or the content that we talked about, that one additional step higher, right? Right at that sweet spot where it gets called once. Now let's talk about takeaways, right? So we went through our hypothetical, we solved the problem, our perf testing team's happy, all the stakeholders happy. We get to ship it. We get to deliver the value to our clients and our customers who now have a performant React Native TV and multi-platform streaming application that they love and works seamlessly as if it was native, right? Awesome. But let's go through the key takeaways so we know how to use this in our everyday work. Because you don't just have to do this. You don't just have to do this when there's a performance fire. You can do this proactively. You could pull this up tomorrow with your code base and just start using these techniques. So assess the end user experience that is currently degrading via target KPIs. Okay, we talked about that. We said, VST was impacted. Again, that was peripherally, which tends to happen, which is disappointing. Additionally, we knew that our screen-to-screen navigation was slow, right? Right, so we define those key performance indicators, right? We spot check each easy to pull metrics such as memory consumption to narrow down the problem, right? Because we know things can get weird with memory. We might as well check it. It's an easy thing to check, right? If determined to be JS related, right? In our case, it was, right? For each KPI that is degrading, define a holistic user journey that captures the given degradation. We did that. We defined the user journey, right? We recorded a profile with that user journey, right? Then we're going to pull up our dev tools. We're going to upload that profile. We're going to pull it off the device. We're going to transform it with that command line command. We're then going to upload it to Chrome DevTools. We're going to start analyzing, right? Then we're going to use our techniques. We're going to zoom out. We're going to utilize the wide bar identification technique, right? To identify the bars on the graph that are the lowest and the widest, right? Then we're gonna go ahead and zoom again back out, and we're gonna press Command F to search for the names of the functions that we found, or the files that we found showing up in our step 1, right, or step 6 in this case, right, our other technique, right? We're going to search for it. We're going to see how many times it happens, the repetitiveness, the pattern. Try to identify the pattern. Why is this pattern happening so much, right? And then we're going to review the total execution time of those wide bars and the frequency, like we talked about. Then we're going to open up your source code at the line number and file, and you're going to go ahead and try to understand what is the actual problem at that line of the code. You might go ahead and find the call sites of it. Then you might go ahead and determine whether or not that's actually needed to be called so much, right? And then you go ahead and solve the problem like we did here. All right, so that's everything I have for you today. Thank you so much. I hope you enjoyed. I hope you have something you can use in your day-to-day. I know this is we have a lot of talks about all the future amazing things that are happening with React Native, and I'm really hoping that this is a little bit different so you can actually use it today and get your app performing very well across all platforms, including TV. My name's Mike Khirallah. Thank you so much.